Hey folks, welcome back. So today I was out and happened to be down by the large waterway, the River Mersey, and I decided to do an observation to confirm: does the horizon rise to eye level or rise up as it would be expected on a flat Earth, or does the horizon dip down? And as things go further away, you see them dip below my eyesight. So I had a finder scope with the crosshairs. I was able to set it level. I had a level. I used the level on my phone, level app, and you can see that with using that, I was able to keep the finder scope nice and level, and we can look out at distance. And there's some way far away. There's some distant hills and stuff, and we'll see if they're below eye level, or if they're at eye level or above eye level. Now the hills are higher altitude than I was, so if it's a flat Earth, they should have been higher than me. So let's have a look and see what works. The globe model says at a very far distance to start to dip down due to the curvature of the Earth, and if they're flat, then they'll actually be higher up because they're higher elevation than I was. So let's look and see which hypothesis is correct. Don't forget to click that like button and subscribe to my channel. It really helps out a lot. Thanks again. Okay, for starters, this is the location I was doing this observation from. And here you can see where I have the scope set up on something nice and stable. And I'm going to show that with using the level app, bubble level app, on my phone, I'm going to hold on top and make sure that the scope is level, and I'm making sure the scope itself is level within the holder itself. So now see here, let's try again here. I was trying to videotape it while I was leveling it to show that I am actually leveling the scope. So pay more attention to the round one, the bubble level in that one there. That one there, you can see that it is level. It's right in the middle there. So that was being me holding on the side. Okay, so now that I've got that showing that it is level, I'm going to hold exactly where I had it, and we're going to see if we can get an observation here. And looking down the sight, see, look at the crosshairs there. As you can see, now this is an inverted image, but you can see that this is showing that the horizon is indeed not rising to eye level as expected on a flat Earth. So I've inverted the image here so that way that the horizon is on the bottom and you can see the crosshairs above it, so you can get a better idea of what I'm talking about. This is going to show here, and down by the water here, probably from the water surface to this, about 6 feet. And invert the image again and look, and as you can see here, with the horizon on the bottom, those crosshairs are above the horizon, above those hills. So I'm still looking here, you can clearly see this. Now this scope inverts the image. This is up in telescope, but it's to show the horizontal of the crosshairs. I'm going to try to level this one more time again. As you can see, that's where the water is and where my scope is. So I'm estimating about 6 feet. The altitude, if you look at Google Maps, it says it's like 0 feet from sea level. This waterway does run straight into the Irish Sea. So this is like actually fresh water and salt water mixed. And we're looking here again into the crosshairs. And then remember that it is inverted so that the top is the horizon, the bottom is the sky inside the scope. But you can clearly see that those crosshairs are above that. So I'm going to look again here. I'm going to double check, making sure it's level. I look at the bubble level there, the round one that's within the circle. So that's indicating that it is level. So I'm going to do another observation here. Just going to check it. Everything is level, as you can see there. So as you're looking here, I'm going to invert the image again. And as you can clearly see, that horizon is below those crosshairs. So this validates the globe model and shows it conforms to reality. So as you can see right there, 3 more observations. And that finder scope was level, and I held it perfectly level. It never moved. That's why you see where I set the camera with the level app on there, and it does. I have tested it. It does show is a pretty good level, is pretty spot on. And when I set it on there, you can see I was just barely touching it, so it wasn't moving the finder scope whatsoever. And you can see I even kept the camera on to try to show that I was going onto the finder scope. And then when you look down that view, you can see clearly that that hill was below eye level, below the crosshairs of the horizontal line, which would have been from that position would have been eye level, right? Looking straight across, nice level observation, looking straight out the horizon, and that hill is dipping below. That's down to the curvature of the Earth. So with doing that observation, it confirmed the hypothesis that the Earth is a globe with curvature and can be easily observed, and falsified the hypothesis required of the flat Earth, that hill would actually have been, the peak of it would have been higher than my eye level, and the horizon would have been rising to eye level as it goes off. So once again, I have falsified the flat Earth hypothesis, and I have shown evidence to support the globe model. Because the Earth is a globe, we are a spheroid orbiting around the Sun in the arm of the Milky Way galaxy, and our Earth does rotate 360 degrees approximately every 24 hours. Thanks for watching. Don't forget to subscribe for more videos, follow me, comment, and look for me on other media as well. Thanks for watching, and see you again.
And by the way, all those rumors on the internet are fake. I'm not flat. I'm not hollow on the inside, and there's definitely no reptilians inside of me!